Hello, this is a very short video to wrap up chapter 15. Two more topics are there: Heisenberg's uncertainty principle and Schrodinger's equation. Just imagine you are in a pitch black, dark room, and all you have to do is find a ball which you don't know where it is. Okay, so you start from one corner, you can't see anything, you keep on going, you keep on going. Wherever you go and you don't find the ball, you think, okay, so far the ball is not in this part of the room, so it should be in the other part of the room. All right, you keep on going. As soon as you touch the ball or your foot touch the ball, it got skinned. So the time you got to know the position of the ball, the next moment, for the next moment, you don't know where the ball has gone. This is the basic idea of Heisenberg's uncertainty principle. Heisenberg proposed that when in an atom, the electron, we are discussing now electron as a wave and not as a particle. So it is very hard to find out what is the exact position of the electron. And therefore he came up with a mathematical equation where delta x represents uncertainty in the position and delta p tells uncertainty in the momentum. He says basically that if you know roughly where the electron physically is, then you cannot tell its momentum. If you know its momentum, you cannot tell the position. It goes like this. So uncertainty, if uncertainty in position it decreases, it means certainty increases. Electron should be in this area, then larger is the uncertainty in its momentum. Smaller is the uncertainty in momentum. If for example you can tell no, the speed of electron is this, and then mv, you can calculate the momentum, then harder it is for you to judge where physically the electron will be. So the equation is delta x times delta p is greater than equal to h by 4 pi. This is a constant value. H is Planck's constant divided by 4 pi. Therefore if you think of it like this, if you bring delta x here, it will go 1 over delta x, right? Delta p greater than equal to h over 4 pi 1 over delta x. So these two quantities are inversely proportional to each other. Alright? And in terms of energy, we can say that uncertainty in energy multiplied by uncertainty in time is also greater than equal to h over 4 pi. Now you will see that how can we look or how can we find an electron? Of course, we are talking about subatomic particles. We cannot see them through our just eyes, right? So what is done, what scientists do, they try to hit the electron with a photon. Okay, and so when photon will hit the electron and come back to the eye, we can sense that, oh, it is coming back from this position. So therefore the position of electron at the time when photon hit it was this. But remember, photon is coming with an energy. As soon as it will hit the electron will move, and then the next moment you will not know where the electron is. That is basically Heisenberg's uncertainty principle. If you know the position, you will not know its momentum. If you know its momentum, you will not know its position. Okay? Best thing is that we don't have to go into mathematics of this for this course, but you should understand the principle that uncertainty in position and uncertainty in momentum, they are inversely proportional to each other. Alright? You all have seen Big Bang Theory. You must have heard about Schrodinger's cat. It's a thought experiment that Schrodinger said that let's have a box, let's put a cat in it, and let's have a glass jar full of poisonous gas or something. So until you open the box, cat can be both alive or dead. That is the uncertainty at subatomic particle. You never know for certain with certainty that what's happening there. Schrodinger gave a wave function for an electron that is called as psi. Si, let me write it down for you. This is known as Si. It's called the wave function of the electron. This equation is just here as a fancy equation. You don't have to even remember it. But Schrodinger equation gives us the probability where electron can be found with the help of, sorry, we just have to square the magnitude of psi. It goes into very much detail of quantum mechanics, so no need to worry about it. What happens next is that actually then it was concluded that electrons just do not go around nucleus in a particular orbit. No, because now we are not seeing electron as a particle, but we are seeing it as a wave, right? So when we are seeing it as a wave, the best thing to imagine an atom is to have a positive center solid nucleus and a cloud of electrons. A cloud of electrons. And it is very hard to determine where the electron is because it is all traveling in a wave form. Okay, so this summarizes your chapter 15. I will have a Zoom meeting with you on Thursday. We will go through the numericals, and on Friday or maybe Monday we will start chapter 16. Bye.